Thanks everyone for coming. So this is a 45-minute talk that I'm going to try and squeeze down into a half hour. All right. So Kotlin's a language. It's a language that targets the Java class file format, the JVM, and it also targets Android and actually JavaScript. So this talk specifically is about Android, obviously, but why do we need Kotlin for Android development? Why is what the tools that we have not sufficient? So one argument that you could potentially make is that we're stuck in this Java 6, almost Java 7 world. So we don't have the new date-time APIs. We don't have the new streaming APIs. We don't have the language features, so lambdas, method references, anonymous classes that don't capture their outer instance. So this is really important for Android because a lot of leaks happen this way, a lot of like activity and context leaks. We don't have try with resources. Try with resources is actually available if you target KitKat and up, but obviously it doesn't work on the lower API levels. So these are some of the arguments one would make about why we could need Kotlin, but I'm actually going to say that these are not great arguments. So for JavaX time, there's a standalone backport. The guy that wrote it for the JDK wrote a standalone version that you can use. For streams, there's also a standalone backport. And there's also a language or a library called RxJava, which is similar in goal, but very different in implementation. It actually provides much more comprehensive composition of streams. There's a tool called RetroLambda that will take Java 8 class files and backport them to Java 6. And this will cover these three things: lambdas, method references, and non-capturing anonymous classes. And then RetroLambda also will do try with resources, so it will do the dance that try with resources does automatically for you. And like I said, even if you're using MinSDK, you don't even have to go this route. So all of these arguments that Java 6 is something that's holding us back are kind of not why we need or would need another language. Two things that do really hinder Android development: just restrictions on how the Java language works and its problems. We have no way to add methods to types that we don't control. So we end up seeing this a lot with util classes. You get util classes that are spread all throughout your packages to add functionality to types. Null is a general problem. There's no way of encapsulating null in the type system, so you never really know if something can be null or not. There's a lot of mutable collections and mutable objects, and so with the heavy threading that an Android app requires, this can cause problems. And then Java itself is just a very verbose language. It has a lot of ceremony around the things that other languages do in a much more terse syntax. So that's the problems of the Java language. We also have Android itself and the Android APIs. So Android loves inheritance. It loves requiring you to extend things, and this severely limits the flexibility of how you create your, say, activities or fragments or views, all of these things that have to extend built-in types. Null is especially problematic on Android because it's a very efficient way of representing the absence of a value, and because Android tries to be as efficient as possible, it uses null all over the place in its APIs. And then back to the ceremony of APIs, Android is especially bad with pushing a lot of burden onto you, the developer, in APIs that require multiple calls in certain orders, or just have a lot of things that you have to do in order to use them correctly. And so these are the things we're going to look at as to why Kotlin will be advantageous. So I said this earlier. Targets JVM and Android. Actually also targets the browser. You can compile Kotlin to JavaScript. But the big thing here is that it's 100% interoperable with Java, and it focuses very heavily on the Java interop. So there's other JVM languages like Scala, for example, which kind of tries to ignore the fact that the Java language and the Java libraries are a thing and re-implement everything. Kotlin takes the opposite approach, where it leans very heavily on the fact that Java is a thing and that the Java standard library is a thing. And so this is by a company called JetBrains. JetBrains are the makers of a suite of IDEs, IntelliJ probably being the one you're most familiar with, which is what Android Studio is based on. So they definitely know their stuff. I'm not going to cover a ton of the actual syntax, but because it's really easy to learn and it's really intuitive, but I'm just going to try and bootstrap your knowledge if you've never seen Kotlin. So this is just how we would define a method. You'll see things you recognize, but some are a little different. Parameters have the name and type reversed. So we put the name of the parameter and then its type. The return type goes at the end of the declaration rather than at the beginning. And you also notice that there's no semicolons. It's a semicolon-free language. An interesting thing about this method declaration, it only has a single expression in the method body. So it's just a return statement of the sum. We can actually get rid of a lot of the syntax around this method body by just inlining the operation that we want to do next to this just by using an equal sign. And you'll also notice we lost the return type. The return type here is unambiguous. It can be inferred to be an int, so we don't have to specify it. Here's what a main method would look like if we were writing a Java app. There's no arrays in the sense that they behave more like how a generic or like a list would work. So in this sense, we're defining it as if it were an array type of string. But when it actually generates the class files, it will turn this into a primitive, or not primitive, but like a native string array. And you also see that in the string, there's string interpolation. So this is really handy. You'll see, giant strings where you're pulling in variables and also mixing them with constant string parts, and you have to do like a bunch of addition, or you're doing a bunch of string builder nonsense. This is a great way of doing that all for you, and it will turn into the string builder, so it'll be very efficient as well. And then finally, this is what like variable declarations look like. So you'll see in the first one here, I'm not declaring a type. Again, this is because the type is unambiguous. It has to be a string. But if we want, this is what a type would look like. You see it's on the right again, just like a parameter. And then there's no new keyword. You basically just lop that off. And also there's no generic being specified when we're creating this array list. It will automatically get the generic from the type on the left. And there's actually no raw types in Kotlin. So if you've ever used like hash set without actually defining a generic, you'll get like a warning. In Kotlin, that's an error. It just doesn't compile. Okay, so we'll see more of Kotlin throughout the talk, and I'll point out interesting syntactical things as we go. But that's pretty much all you need to understand what's going to be happening in the rest of the talk. So extension functions exist to fix that util problem. So what we would do in Java, we would define just a static method that takes a argument of some type, and then it does some behavior. And we would call this like you would call any other static method. And so an extension function is going to allow us to take this method and transplant it onto date itself. So we can call it from any date object. The way that we define it is like this. So it looks like our standard method, but the one thing that's different is we have now included the type that we want the method to be present on in front of the method name. And so now if we have a date instance, we can just call this method like any other method that already exists on date. Another interesting thing syntactically about Kotlin is that it will actually synthesize what's called properties from getters and setters. So this date type has a getDay and a setDay method. And so Kotlin will actually turn that into a single property called day that you can both read from and write from. And under the hood, it will call the getter and call the setter when you're assigning it. So in this case, it'd be calling the getter. And then hopefully you remember what we can do to methods that have a single expression in their body. We can just get rid of a bunch of the boilerplate. And so in like 22 characters, we've defined this extension method that we can call now as like it was any other method on our date objects. Something interesting to note is that this actually doesn't work everywhere out of the box. It will only work if it's in the same file or the same package. So if we're in separate packages, if I'm defining my extension function outside of my package where I want to consume it, this will actually fail to compile. That's because extensions are statically resolved at compile time. So you actually would have to do an import in order to get this code to compile. And what's great is that this method behaves like any other method. So the fact that it's imported, you can like command B into it and you get the Java doc and all that stuff. It behaves like any other method. So the Kotlin compiler is going to generate this bytecode when we add this extension function. And so if you're not familiar with looking at bytecode, this is what the equivalent Java code is that also generates that bytecode. And you'll notice that it's exactly the same Java code that we wrote, that I wrote at that first slide. So even though we're using this much more rich syntax and a much better experience interacting with this method, it ends up being the same exact code being generated, so it has the same performance characteristics. There's no cost to this this abstraction, or not really abstraction, but this feature. So this is going to end up in a file called date extensions kt. So there's no actual Java file, right? This is just a representation. So it'll actually be in date extensions kt.class. And so, like I said, Kotlin emphasizes Java interop very heavily. So you can actually control the name of this file because you might not want date extensions kt to be in your Java code. You can use a file level annotation to specify what the name of the generated class is. So in this case, we can go back to our good friend dateUtils, and the generated static method will be in a dateUtils class, which you can then call from Java, and it behaves like it was just a dateUtils class written in Java. So the Java people are none the wiser, and the Kotlin people get all that extra functionality. So extension functions can't override existing methods. So if I wanted my isTuesday method to always return true, I can't override getDay to always return Tuesday. That doesn't work. So it's kind of unfortunate because in Android, this would be a fantastic way to shim backported APIs. So we could add a method to, say, view, which calls a compatibility implementation when the real method's not available, and calls the real method when it is available. So we can't do this. If you wanted, you could still add an extension method, but you just have to add some sort of prefix or suffix to differentiate it. Kind of unfortunate. All right, let's take a look at another case. So database interaction is, we get right into kind of the ceremony of APIs of Android. So in order to just get a value out of a cursor, we have to call two methods, one to get its index and one to read the value as a certain type. And actually, if this column is nullable, we have to add even more ceremony. We have to first check if the column is null before reading its value. So doing this for every column it's ridiculous. We shouldn't have to do this. So let's see how an extension function could make this better. We could define two methods, one that gets a nullable type and one that gets a non-nullable type. And we would just be able to call it on any cursor object. Okay, so interesting things to note here that we haven't seen. The return type of the nullable method has a question mark at the end. And so this is a representation of a nullable type. The type system knows that this may be null. And what that's going to do is it's actually going to force you to think about what happens when it's null. Okay, so we're not defining a type on the field, but the type would be string question mark, which means that in order to actually use this, in order to actually get the string value, you would have to do a null check first. And then inside this if block, first name, because Kotlin knows that you did the null check, you can use first name anywhere inside that if block as a normal string, as a non-null string. We know inside that if block that it will never be null. So if setText only accepted a string and not a string question mark, you would be able to call it here. But if you tried calling it outside of the if statement, it actually would fail to compile. Another handy syntax here is if you have a nullable type, you can supply a default value if it's null. So we could do this as well for people that don't have first names. They all get the first name of Jake. Okay, another thing to look at is in the overload where we're saying that it's a column that will never be null. We're just going to delegate to the nullable function, and then we're going to append two exclamation marks. And this is basically saying, I know that this return type will never be null, so just unwrap it into a non-null type. So this will actually emit an assertion. So if it is null at runtime, it'll throw an exception. But it tells the type system that you are accepting the responsibility of the fact that you think it will never be null. And so now our variable is just a normal string, and we could just call our setText method, which only accepted a string, without an if check. So killing hundreds of bugs with nullability problems and null pointer exceptions in the type system. All right, so I'm going to breeze through function expressions because we're going to see it a lot. But this is basically just what you would call a lambda or closure anywhere else. And it's just a way to represent code, a piece of code as an instance. So I can take some string or take some object and convert it to string. And so it here is special. If you have a function expression which only accepts one argument, it implicitly is called it. And so here's an example with two arguments. So we can actually define named arguments. And so these are instances, these are just like blocks that we can move around that are executable code. We can give types to the arguments, and this is how we would represent it, store it as fields. And so I know I'm breezing through this. We're going to see it a lot later in better examples anyway. But the one thing I want to point out is that this is how you represent a function expression in the type system. So the type of this sum field is a function itself. It's a function that takes two integers and returns an integer. So sum is a block of code that we can execute by giving it two integers, and it will give us back an integer. Just for another example of why these are useful, we could do like text validation with these. We could create validators and then pass it to, say, an edit text, and it could do validation. And so we're actually going to come back to this sample, so I'm just flying through that one. Okay, higher order functions. This is where we're going to start getting into a little bit more useful things. This is just like a really mathy term for methods that accept other or functions that accept other functions, or functions that return functions. And so that basically just, to illustrate this, let's write a filter function. And so you'll see that this filter function accepts a function which we can use to determine whether or not we want to keep or remove each item in the list. So it's accepting a function that takes the generic type and then returns a Boolean of whether we want to keep it or not. And then you'll see that this is also an extension function. So we can, if we have a list, we can just call filter on it. So we would implement this like you would implement a normal static method filtering. You loop over the list, create a new list, loop over items in the list. We would call the function that's being passed in for every item. And if that function returns true, we just retain it and return the new list at the end. And so here's how we call it. And so the very last line, you see a function expression, an expression that represents a function, which is something that takes in an instance as its only argument. So we can use the it shorthand. And then it returns a Boolean because it's doing an equality comparison, which we know returns a Boolean. And so the jakes variable here will retain only the jakes in the list. And thankfully, you don't have to create this function. This is actually one of the ones that's built into the Kotlin standard library. A lot of the standard library just exists to add functionality to existing Java types. So we don't have to write this one. But there's ones that we can write in order to go back to preventing bugs and simplifying our code. So this is a way of basically synchronizing access to a certain instance without doing. It's a little bit different because it prevents accessing it from outside of a synchronized block. So I'll quickly look at data class. This is a shorthand for basically generating equals hash code and toString on a value type. So we're going to get that for free. This is the declaration of both a constructor and fields. So we're declaring that this lock takes in a an object of type T, so any type, in its constructor, and it stores it in a private variable so it can't be accessed publicly. And then you'll see this is our higher order function. It takes in a function that receives the instance, and then unit is the word for void. It returns nothing. So how do we use this? We create a lock, and we give it some object. So in this case, I've given it a JSON reader, and so this JSON reader is doesn't support multi-threading. It has to be accessed from a single thread, or at least by one thread at a time. And so now the only way to get this JSON reader back out of the lock is to call this acquire method. And the acquire method will wait until it can actually get exclusive access to the JSON reader before calling your code, and then your code will run. So unless you deliberately somehow leak the instance that's being passed to you, the code inside of these acquire blocks, it's impossible to have them run concurrently. The synchronization is taking care of ensuring that only one of these blocks run at once, and you don't have to deal with maintaining like a separate lock and an instance, or if you like have two variables that you need to access, you could write some kind of dual lock, but basically encapsulating the semantics of the lock inside of a class and then simplifying it so that you just provide a bit of code that you want to run whenever you need to access that instance. And so going back to the function expression examples of doing validation, we could write a extension function on edit text that did validation. As you're typing, it validates it with some block of code. And so we could just call that method with these function expressions that we define. An interesting thing to note here is that each one of these function expressions amounts to like an inner class, like an anonymous inner class. So if we were writing this in Java, we would want to pass, an instance of an anonymous inner class to this method, and it would just call a method on that class every time you type something. So the first name and last name here are just validating whether or not something's empty. And even though it's the same block of code, it's actually not going to be deduplicated. So this will generate two classes. It will generate two instances, and it's just something to be aware of. So if you're like writing the same function expression, the same like filter, or the same map or whatever multiple times, you're going to end up creating kind of a bunch of garbage in your APK and bloating it potentially. So just something to be aware of, but we can like manually deduplicate this. So we're only creating that function expression once, and then we're just passing it to both. Another cool thing is that I talked about the non-capturing aspect. So this is where if we define an anonymous inner class, like inside of an activity, that inner class is going to have a reference to the activity. And so if that you pass that inner class to something that lives longer than the activity, you're going to end up leaking it. However, because these function expressions don't reference anything outside of their scope, they're just dealing with the argument that's passed in, the it. They're actually going to be generated as static classes, which have no access to the outer scope whatsoever. So it's impossible to leak the outer reference unless you're explicitly referencing it. Okay, so extension function expressions. This is a terrible term, but it's absolutely fantastic, and it's the culmination of the last three things that we looked at. It combines all three. So it combines the extension functions, adding methods that don't exist on a type. It combines function expressions, which are just representations of code as data, the ability to move around blocks of code as data, in fields and passing it to methods. And higher order functions, which is just shorthand for functions that accept other functions, like our filter function. Okay, so the example I'm going to use, I really want to show how these, the language and the way that you can write these functions potentially reduces whole classes of bugs in your app. So database interaction is something that is tricky and has the potential to create subtle bugs in your app that you might not actually find. So for example, this code actually has a bug in it. we're not calling set transaction successful before the end of our try block. And so every time you interact with a database, if you're doing something where you need to use transactions, you have to remember to do this whole dance. Begin the transaction, try block, execute everything that you want to do. The very last thing has to be setting it successful. You can't put successful anywhere higher up in the try block. You need the finally block, and you need to end the transaction. This is a lot of ceremony just to do something simple, a simple interaction. So let's kill all that ceremony. We define an extension method on the database, which takes in a function that runs inside of a transaction, inside of all that ceremony. So it's responsible for starting the transaction. It's responsible for the try finally block. It's responsible for marking it successful, and it's responsible for ending it. And it runs your code exactly when it has to. And it means your code doesn't have to worry about any of this. So now if we have a database, we can call our extension method, pass it a block, and inside that block we can do whatever we want. We do our database interaction, and it takes care of the entire transaction behind the scenes. We never have to worry about writing or even worse, screwing up that code ever again. Okay, so I would argue that this is fantastic, but it's not ideal. So what I'm going to do is make some changes here to show you how this can get even more ridiculously awesome. So right now it's accepting a function that doesn't take anything in and doesn't return anything. It's just a block of code that just runs at the right time. And so that causes us to reference the database when we're creating the transaction and inside the transaction when we need to do something. So a simple optimization we can make is just, why don't we pass the right database in? If for whatever reason you had two databases, you don't want to reference the wrong one inside the other one's transaction. So we can pass the current database into the function expression. So now when we call the function, we just pass in this, because remember this is an extension method, so it behaves as if it's defined inside the SQLite database class. And then down in our consuming code, we just switch this from referencing the database directly to referencing the argument that's passed in. And so now there's some other bugs that we potentially eliminated, but this is still kind of annoying, right? We still have to specify it every single time we interact with the database. Like, we're inside this transaction, we know what database we want to interact with. Why do we have to specify it every single time? If we go back to our function expression definition in the parameter, we can actually change it to be an extension method of the database itself. So this is going full kind of inception here. So the function that we pass into the transaction method will itself be an extension method of that database. So now we're no longer passing this in. We're calling the function which exists on the database itself. And so if you're calling this, we can just kind of eliminate that. And then what does that do to our calling code? Before we had to reference the database, now we're a method that exists on the database. So we don't have to specify anything. We can just specify delete, because delete is another method on the database, and we're a method on the database. And so now our code has turned into this. We reference the database only once. We do no ceremony around transactions. Every operation that we want to do on the database is encapsulated in this block, and we don't have to qualify any of the interactions because we are basically operating as if we were inside of the database itself. So this is pretty fantastic. And so earlier on with extension functions, I showed the generated code. And so this is what the generated code for this transaction block looks like. And so in Java, it actually looks like this. It's our static method. Our extension method gets turned into a static method. But like I said, our function expressions turn into anonymous classes, anonymous inner classes. So this is what it ends up look like. So that means that every time you want to interact with the database, we actually have to create this function. We have to generate this function class and create an instance of it that has your code inside, create an instance of it, and pass it to that static method. And so if you're using these extension functions expressions all over your app, thousands of places to reduce problems, you're going to be generating a ton of these extra objects. And so On Android, we're very allocation aware. It's these small disconnected phones, tiny, not inefficient, but not exceedingly smart garbage collectors. We want to avoid creating any unnecessary objects. So one thing that we can do, a language feature of Kotlin, is that there's actually an inline qualifier that we can specify. And what this is going to do is it's going to take, instead of creating an instance of something, passing it to the method, and having that code run, it's going to invert the relationship. It's going to take where we're calling the method, grab the body of that method, and pull it into the call site. So now we generate this whole bunch of crap, which in Java is exactly what we want. It's the original code again. The original ceremony of the try finally, the two interactions for the transaction, setting it successful in the right place, and our code. This is what gets generated. So again, we're back to zero cost abstraction. We've hidden all the complexity, but the actual generated code is exactly the same as if we would have written it by hand. So for Android, a general rule is that if you're dealing with these extension function expressions, more often than not, in fact, almost always, they should be inline functions because that just reduces, effectively eliminates the overhead of them. And so you can apply this all over. I mean, pick your least favorite API of Android, and you can probably remedy it in some way. So shared preferences is another transaction-based API. So here we're taking in we're adding a method to shared preferences, and we're taking in a method that exists on the editor that's created when you start the transaction. And so now our preferences interaction has been simplified. You never forget to call apply, which sometimes happens. But what's cool is that this is only a half-hour talk. Kotlin has just a ton of really awesome language features that are that can really do wonders to your code. So remove here down at the bottom looks pretty nice, but put strings looks a little out of place, at least to me. So let's throw on another extension method to the editor, which is called set, and it takes this pair. A pair is just an object that holds two other objects, in this case the key and the value. What's great about pair is that Kotlin actually has a built-in function which allows you to use a special syntax of creating a pair. So we can now call our set method, and we can use this to method. This is actually a method, the to. It's just an infix method. An infix method means that it's something that accepts two arguments, and rather than using the name and then specifying the two arguments, you specify the first argument, then the name of the method, and then the second argument. So to is a factory for pairs, and so it's going to create a pair that has these two strings and then just pass it to our set method, and then our set method is just going to call put string. And so we've turned preference interaction into this nice high level, almost like English DSL, where we can never forget to call apply. And this is all over. So even if it's not the most terrible API, you can add these extension function expressions for no cost, zero cost abstraction. So pick anyone. Here's notification just for the hell of it. And if you even wanted to, you could make this actually show the notification at the end of the block. So you would never forget to show a notification. You would never forget to show a toast or whatever. Anything that you ever have thought, man, this is such a stupid bug. How could I have made this mistake? That's exactly what these are for. Eliminate the ability to make that mistake. So an interesting application of extension function expressions that's available for Android is actually by JetBrains. They've kind of taken this pretty far, and they've generated these dynamically from the view types that exist that we use to create our views. And so what you can actually do is replace XML with extension function expressions that generate the instances of the types that would be the same as if you had written in XML and then inflated it. And so this is basically equivalent to a linear layout that's vertical, that has padding, has nested edit text, and has a button. And so because of the power of these things, It basically hides all of the ugliness. If you've ever tried to do manual view instantiation in Java, you know that this would be like probably about 40 or 50 lines. And so they've encapsulated it in these extension functions expressions which hide all that boilerplate. It actually shows the hierarchy still, which is nice. You have that same nested hierarchy that you would get in XML. And it's also very declarative. So you can see hint and text size here are those dynamic properties. So there's actually a get hint and a set hint method on text view and get text size and set text size, etc. All right, so I said this before, but there's just a ton to Kotlin that not only I can't cover, but it's just waiting to be discovered and figured out how it can be applied to Android. So their documentation is actually absolutely fantastic. It's super easy to understand. It covers pretty much the entirety of the language. Definitely check that out. You don't even have to set anything up to use it. There's an online JavaScript IDE where you can create and run projects and actually share them. And they have, just recently, they created this interactive tutorial that shows you a bunch of the language features and allows you to learn them kind of naturally and organically. All right, and so that's pretty much all I have. Kotlin is in its second 1.0 beta, so they're aiming for 1.0 by the end of the year and are looking like they're probably going to reach it. So there's certain aspects of Kotlin that they haven't been focusing on. Things like compiler performance comes up a lot. They've been focused on the language itself and getting that stable so that people will actually start using it and can rely on its stability, and then improving things like tooling support, compilation, all that stuff. So yeah, that's all I have. We don't have too much time here. I was right up on 30 minutes, so if anyone has any questions, I'd be happy to take one or two. But otherwise, thanks.